In previous sections, we talked about and went over a few different types of special products of polynomials. And now what we're going to do is kind of look at that in the reverse and identify how we can factor using the inverse of those special products. What we're going to take a look at is unique in this set of special cases, and that is the only one that's not a binomial, and that is our perfect square trinomial. Now, the perfect square trinomial is the result of squaring a binomial. So when we go in reverse, a perfect square trinomial always factors to be a binomial squared. Now it's going to follow a very similar pattern. We've seen this pattern in reverse, and so now we're just going to look at it from a different angle. Now what we want to be able to do is identify what constitutes a perfect square trinomial. And one of the easiest ways that I consider is first looking at the first and last term and identifying, are those perfect squared terms? Now I want you to recall what constitutes a perfect square. Well, the perfect square is going to be the square of any integer. And so if we square the number 1, we get 1. If we square the number 2, we get 4. We square the number 3, we get 9. And we follow that pattern with 4, 5, 6, 7, and so on. We get a bunch of different squared values. Okay, these are all the squares of an integer. And so these are what we refer to as perfect squares. If we're thinking about variables, x squared is x squared. X to the second power squared is x to the fourth. X to the third power squared is x to the sixth. And we can continue that pattern, x to the eighth, x to the 10th. Any even exponent is going to be a perfect square quantity when variables are concerned. And so we see here with this factor, we've got 16x squared and 9y squared. These are both perfect squared quantities. And so what we can do is figure out, well, what quantity squared would be what each of these are. What's the a value? If 16x squared equals a squared, well, a would be 4x. And then if 9y squared is b squared, then 3y equals b. And so the first thing we do is we look at the first and last term and try to identify, are these squared quantities? And then identify what those quantities would be. Then what we have to do is perform a check, where the middle term has to be 2 times a times b. And so if we take 4x, which is our value for a, and we take 3y, which is our value for b, if we multiply these and then multiply it by 2, we have to see, do we get this middle value? And if we multiply 2 times 4 to get 8 times 3, we get 24xy. So that is the middle value, which means that it does count as a perfect square trinomial. Since it does qualify as a perfect square trinomial, then factoring just means that we take the values of a and the value of b, we set it into a binomial squared, where the sign, the operation, matches the operation at the front of the trinomial. So let's take a look at a couple examples. Once you get the pattern, it ends up being a process that's really, really quick. And don't forget that we always need to check for GCF first, especially when we have a leading coefficient. So here we look and we see, okay, well, m squared is a squared quantity of m. 25 is a squared quantity of 5. Well, now we need to check to see if it's a perfect square trinomial. So we take the value for a, which is m, the value for b, which is 5, and we multiply it by 2. And we get 10m. Since 10m is my middle term, then I know it's a perfect square trinomial. So all we have to do for the operator is take the operator from the front of the trinomial and make the quantity squared. And that's it. We're done. We factored it. M plus 5 squared is equivalent to m squared plus 10m plus 25. For b, we see that we have squared quantities. 9x squared is the square of 3x, and 4 is the square of 2. We do our check, and c is 3x times 2 equal to 12x. Well, 2 times 3 is 6, times 2 is 12x. So since that equals our middle term, we'll have our binomial squared, and this operator will match from the beginning of the trinomial. Now here we look at our first and last term, and we see that, well, these are not squared quantities. However, we do notice that 12, 12, and 3 have a common factor, as well as x being a common factor. So we do have a GCF of 3x, which does adjust our trinomial to 4a squared minus 4ab plus b squared. Now these are squared quantities of 2a and b, and if we multiply 2a and b by 2, we get 4ab, which is our middle term, so it factors to be 2a minus b squared, and then don't forget our GCF.